All right, so finishing up section 1.6. This screen makes it look way scarier than it is. If you're solving radical equations in the form with fraction exponents. So first of all, we need to remember that at some point we have learned that if I have a raised to the m over n power, that means the nth root of a to the m. So a fraction exponent really just means a radical. All right, so what we're going to do is ignore half of the words because it makes it way worse than it needs to be. To solve when you have rational exponents, you're going to isolate the expression with the rational exponent. So basically get the variable by itself so that it looks something like this. And then you're going to raise both sides to the reciprocal power. The reason that you do that is because we know that if we have a to the m and we raise it to another power, then we're just going to multiply those two powers. We also know that if I have like 2/3 and I multiply that by 3/2, I get 6/6 or 1. So if I can raise to the reciprocal power, I'm going to make those exponents go away. All right, so if it looks like this or it looks like this, those are the same thing except for this plus or minus. So what this is saying is when you raise to the reciprocal power, if m is even, that means you end up taking an even root. So you have to put plus or minus. All right, we're going to work it out so we see that we're taking an even root and know to put the plus or minus. If you're taking an odd root, then you don't have to put plus or minus. All right, and then make sure you check your solutions. I don't usually find extraneous solutions with these, but if you start out where you have an even root, there's the possibility of extraneous solutions, so checking is a good idea, at least mentally. Okay. So here are our examples. And again, remember that last slide I said makes it seem way more difficult than it is. So I want you to take a deep breath and understand it's not going to be hard, but we do need to move all of these down to give me plenty of room to work. Bear with me. I should have done this. I knew from the last lesson there was going to be a problem. Okay. These are easier to move. Slide that guy down. Slide that guy down. All right, back up to work our problems. Here we go. So we need the variable by itself, so we're going to add 8 to the other side. So if we add 8 to -4, we get +4. All right, so now if I raise this to the 3/2, which is just this guy flipped over, then I'm just going to get x to the first, x to the 6/6, or x to the first. But if I'm going to raise one side to a power, I've got to raise the other side to a power. All right, so what I'm going to do here, I can just type this in my calculator, but we can also write it using that property. We know that it's going to be the square root of 4 to the third. So the square root of 4 to the third. All right, so square root, that means stick a plus or minus because it's an even root. All right, so we have x is equal to plus or minus 2 to the third, and then 2 to the third power is 8, so plus or minus 8. All right, so then we're going to check our answers. So think 8 to the 2/3 means the cube root of 8 squared, or in your calculator, you do 8, then the little exponent button, and then 3/2. And my calculator says you can't do that. That's because it's to the 2/3. Okay, you get 4. All right, so 4 minus 8 is -4. All right, if we do -8, so I'm taking my calculator and I'm doing -8 raised to the 2/3 power. I have an old calculator. I'm trying to make sure I get all the parentheses in the right place. Then we also get 4 because the cube root of -8 is -2. Square that, you get +4. And again, 4 minus 8 is -4. So both of these work. All right. So again, all I was doing was taking my answer, putting it in X, and typing it in my calculator. And it gives me a 4 whether it's a positive 8 or a negative 8 that I plug in there with my calculator. So both of these work. All right, so this one, we're going to divide by 4 on both sides. So we have x to the 3/2 is equal to 108 divided by 4. I want to say is 36. No, it's not. It's 27. All right, so then to get x by itself, we raise to the reciprocal, so to the 2/3. So this side gets raised to the 2/3. So we get x. And then this is the cube root of 27 squared. Can you just type this in your calculator and get an answer? Absolutely, but your calculator is not going to give you the plus or minus. So taking the time to do this, we see that we have an odd root, so we do not need a plus or minus. We know the cube root of 27 is 3. And we know 3 squared is 9. And if you go back and check your answer, if you do 9 raised to the 3/2 power, you get 27 times 4 is 108. So we know it works. Okay, if you have ones that look like this, same concept, you just have an extra step at the end. So to get rid of this 2/3, because it's the thing raised to the powers by itself, we're going to raise this whole side to the 3/2. This side also to the 3/2. So x minus 4 falls out. This is the square root of 16 to the 3rd. So since it's an even root to square root, we're going to put plus or minus. So x minus 4 equals plus or minus. The square root of 16 is 4. Raise that to the 3rd. So that's plus or minus, what is that, 64? All right. I would put a star by this one because I think it might be on your test. All right, so we're going to add 4. But remember that this is equal to 64, and this is equal to negative 64. So if I add 4 to positive 64, I get 68. If I add 4 to negative 64, I get negative 60. All right, so again, we're going to plug in those answers. If I do 68 minus 4, that's 64. So 64 raised to the 2/3 power is 16. Check, that works. If I do negative 60 minus 4, I get negative 64. If I raise that to the 2/3 power, I also get 16. So both of those work. All right, so for the next one, we're going to raise to the 5/4 because that's the reciprocal of 4/5. So x minus 3 comes out. This is the 4th root of 16 to the 5th. So because it's an even root, we need plus or minus. The 4th root of 16 is 2. 2 to the 5th is 32. And again, you can use your calculator to get those values if you don't know them. There's also charts hanging in the classroom. All right, so you're going to add the 3. But remember, because of the plus or minus, it's technically 2 little equations that you have going here. So add 3 to positive 32, and you get 35. If we add 3 to negative 32, you get negative 29. All right, so again, mentally going back and checking, 35 minus 3 is 32. If you raise that to the 4/5 power with your calculator, you're going to get 16. So it works. If we take negative 29 and subtract 3, that's negative 32. If you raise that to the 4/5 power, you get 16. All right, so again, like I said, checking them, you're supposed to, but I've never run across one of these that really had an extraneous solution. So if you don't check them, you should be okay. All right, so absolute value equations is the other. So we have to understand what absolute value means. So it's distance from 0. An absolute value equation is an equation that has an absolute value in it. So remember, absolute value are these little bars right here. There is no way to undo absolute value. You just have to use the definition of its distance from 0. So to get rid of those absolute value bars, this is supposed to all be one sentence, by the way. I don't know why it got all separated like that. If you have this, then you just rewrite it as two different statements, because if this were, let's say, absolute value of x is equal to 30, then on a number line, a very crooked one, sorry, 3 units from 0 is positive 3, but it's also negative 3. So you would say that x is 3 and x is negative 3. Both of those numbers are 3 units from 0. So both of those could have been what x was before I took the absolute value. So just simply to start with, if I say absolute value of x is 10, then to get rid of the bars, you say x is 10 or x is negative 10. If I ask you for absolute value of x is equal to negative 10, you stop and say, no, you can't do that because distance can't be negative. All right, so let's work with solving some equations. All right, so we have to have absolute value by itself before we can make two problems. All right, so if you need steps for this, step 1 is get the absolute value by itself. Then break it into two problems, solve both problems. So absolute value is by itself. So we're going to use the definition to separate it into two problems. So either 2x minus 1 was 5, or it was negative 5. Then we did absolute value and we got 5. All right, if we solve this, we're going to add 1 and divide by 2. We're going to add 1 and divide by 2. And those are the two answers. Absolute value makes a V shape, so it should have two solutions. It's possible that it only has one or none, but usually it's going to have two. All right, we're trying to get absolute value by itself. Remember, that's step 1. Never distribute. Put a big old star on your paper and write that down. Never distribute into absolute value. We're going to add the 20. We're going to have patience. We're going to divide by the 4. These are absolute value bars. They should be bigger than everything else. Divide by the 4. Writing minus a number is very difficult with this little pad. All right, then you get to make your two problems. Either this was 5 or it was negative 5. All right, so if we subtract 1, then negative 2x is equal to 4, which gives us negative 2. If we subtract 1 over here, because that's a 1, not a parenthesis, then negative 2x is equal to negative 6. So x is 3. All right, so on to the next one. If we subtract 8, because we want absolute value by itself, then we end up with negative 3. So this is your cue to stop and think. Absolute value equals negative 3. The difference between these numbers, the distance between these numbers is negative 3. That cannot happen. So it's no solution. All right, so working this one, I'm going to clear all this out so that's not confusing you. All right, so here we have absolute value of x plus 5 times 2 minus 15. So we've got to add 15 as our first step. So if I add 15 to negative 7, I get 8. Then we divide by 2. And you have 4. All right, so you see how this is equal to negative. Some people will stop and say no solution. Well, you can't say no solution until the bars are by themselves. So until you get to this point, you don't know whether it's no solution. So at this point, it's all worked itself out. It's now equal to a positive, so it's good. So we work our two problems. X plus 5 is 4. X plus 5 is negative 4. Another big mistake that people will make is they want to change what's going on inside here. You never change that. That stays the same. You just change the answer parts. All right, so subtract 5, you get negative 1. Subtract 5 here, you get negative 9. They also want to just magically like give me this answer in the positive and negative form, and that's not right either. You have to write 2 problems and solve both of them. You should get 2 different answers, not just positive, negative of the same thing. All right. Like always, if you have questions, please let me know. Here's your assignment. If you're working through it and you get into some trouble, send me an email. I'll be happy to work a problem for you.